Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today's episode is brought to you by Why Dinosaurs, the feature-length documentary celebrating dinosaurs and the people who love them, created by father and son team Tony and James Pinto. If you want to learn more about the project or support it, head over to whydinosaurs.com. Today, in our 261st episode, we have a bunch of dinosaur news, including a new dinosaur from South America, which is super important and super interesting and awesome. I'm really excited about it. As well as another Oryctodromeus burrow, which was found, but this time in Idaho, as well as some other news from around the world. We also have an interview with Dr. Stuart Sumida, who we interviewed at SVP. It's the last of our SVP interviews, but definitely not the last of our Australian interviews. We have a lot more of those to come. And we have Dinosaur of the Day, Pelecanimimus. But before we get into all of that, we always like to thank some of our patrons who have been keeping the show running all year long. And this week we'd like to thank Chris, Nicholas, Trent Carbajal, Stefan, Nutmeg, Taya, Stego Sophie, Ayumi, Paula Canthus, Jackson Crawford, Sorian Brandy, Mayu, Dino Bo, Mello Stego, and Wiki.
Yeah, thank you so much for all of your support. As Garrett mentioned, that's really helped us keep the show going this year. So if you want to join this amazing group of people, then check out our page at patreon.com/iknowdino.
You could give us a little Christmas gift or other holiday gift. We'll accept any sort of holiday gift that you want to give us. Jumping into the news, up first is the new dinosaur, which I already mentioned. The paper was written by Christian Pacheco and others and published in PeerJ. It's an open article too, so you can look at it if you want. It's from Brazil. It's not a sauropod.
No. Is that what makes it so interesting to you?
Sort of. What really makes it important, though, is that it's a very early dinosaur. So this one is named Gnathovorax cabreirai, and Gnathovorax translates to the Greek for jaws inclined to devour.
Wow.
In other words, it has good eating mouth.
Teeth.
Yeah, there we go.
Strong teeth and jaws. That's quite the name.
Yeah, it's pretty cool. And then cabreirai is after the paleontologist who found the fossil. And there's actually a really excellent YouTube video of the whole find and kind of the process of the find, the prep work, the fossils themselves, and all of that. Unfortunately, it's all in Portuguese, unfortunately for me at least, not unfortunately for any Brazilian listeners. And there's no subtitles. But they do show Sergio Cabrera finding out that it's named after him.
Oh.
And it's really awesome. He's like so touched by it. It's really cool.
That's nice.
Yeah, it's a good video. Even if you don't speak Portuguese, I enjoyed it without that. So on to what Gnathovorax actually is. So it's about 233 million years old. And somehow, despite being that old, it's in really amazing shape. And if you're familiar with when dinosaurs evolved, you know 233 million years old is way at the beginning. It's like probably within 10 million years of the very first dinosaur. So it's very important. And in the paper, they say it's, quote, the most complete and best preserved Herrerasaurid dinosaur ever found, end quote. And they pointed out that Herrerasaurus, the Herrerasaurid Herrerasaurus, is pretty well known too, but it's a composite of individuals. So it's not one individual dinosaur that was found. They had to piece together what Herrerasaurus was from a bunch of different individuals. Whereas this one, Gnathovorax, was found as just one individual and is incredibly complete. It's really awesome.
Cool.
It's also only the second Herrerasaurid ever found in Brazil, and the other one was found about 80 years ago.
It's been a while.
Yeah. So Gnathovorax includes a nearly complete and articulated skeleton.
Oh, that's nice.
Yeah, it's basically only missing bones that can be inferred from their mirror image, like the right leg. And it's got like the complete tail, the complete skull, a complete arm and leg and ribs. And I think it even has gastralia, if I was looking at the skeletal drawing right. But yeah, it's a really, really great find. And the skull is in really good shape too, which is awesome.
That's better preserved than a lot of dinosaurs, not just Herrerasaurids.
Yeah, it's in the very upper echelons of well-preserved dinosaurs for sure. And the fact that it's from the Triassic, when usually the older you get, things start to get more sparse, is just extra awesome. So quick background on Herrerasaurids, because we don't talk about them that often. Like I said, they're not all that common. They only existed during the Triassic. They were extinct about 10 million years before the Triassic ended. So there aren't all that many formations that have Herrerasaurids, mostly in South America. And even then, they're usually pretty fragmentary. But what we do know about them, in general, Herrerasaurids are relatively small. You can think more of a Deinonychus size than a Utah raptor size. So that's smaller predator, I would say, somewhere in the 4 to 6 meter sub 20 foot scale. So yeah, pretty small
for a dinosaur.
Yeah, and the authors call them medium to large bodied. And I think that's because Triassic dinosaurs were in general a lot smaller than later dinosaurs. So at the time it was pretty big. So it was one of the bigger predators for sure. But yeah, compared to something like a T-Rex or an Allosaurus or something, this one's pretty small. And it also was a lot skinnier than later carnivores at that same length. So just the length alone doesn't really give you the full picture of it. Gnathovorax also had a boxy head. It was kind of like an early sauropodomorph. You could kind of think of Plateosaurus, kind of, that same sort of early...
Well, all the early dinosaurs had a similar look.
Yeah, they did. And they don't look particularly well adapted for anything. Kind of generalists is sort of how they look, with a head that doesn't look like it had really strong jaws. And with Plateosaurus, you're like, really? That could do anything with plants even? Like, what's going on? This one has really sharp teeth, so you can tell, like, the authors named it, it's intended or inclined to devour. But yeah, it's not really an apex predator like you'd see in something like a T-Rex, sort of really functionally designed for crushing bone or ripping through flesh. And it also had some other really weird features that all Herrerasaurids have, like having 5 toes, although only 3 were really functional. So it sort of is theropod-like, but, if you look at the bones, you can tell it's different.
Yeah. It's early days.
Yep. And like all the early dinosaurs, it was bipedal, and the hands were also superficially theropod-like, probably good for grasping. It had pretty curved claws and, hand-like hands, not T-Rex weird fingers or like Carnotaurus little baby arms. This one still had real arms that could actually pick something up. In general, I think Herrerasaurids are basically like an early attempt at theropods that just didn't quite pan out. It has a lot of the same sort of attributes, but it's just not quite there yet. And because it has so many weird features, and also because they're so not well known, we have a lot of fragmentary individuals, they're one of the most troubling groups for paleontologists to fit into cladograms. So in order to fit them into that early dinosaur family tree and see where they fit is really hard to do. Sometimes Herrerasaurids are separated from all the other dinosaurs and they're totally alone. Like, I think that often happens with Ornithoscelida, if I remember right. Herrerasaurids will kind of be off on their own. Sometimes they get included with Saurischians, and even when they're included with Saurischians, they can vary where they exactly are. Sometimes they're basically like a sauropodomorph, probably because its head looks sort of like a Plateosaurus. Sometimes they're more like theropods because of the toes and hands and things like that. But the consensus now seems to be that it's a little bit more like a theropod than anything else. So back to Gnathovorax. Gnathovorax is 2 million years older than Herrerasaurus, which is only 231 million years old. It's just a little baby. And Gnathovorax was found in the southernmost state in Brazil, which I think is pronounced something like Rio Grande do Sul. Most Herrerasaurids come from Argentina, and like I said, this is only the second one from Brazil in general, so it's pretty cool. And fortunately, this one was found near Santa Maria, and even more fortunately, in Santa Maria, there's a university with a paleontology program. I don't really know if that's the fortunate side. It might be more like the only reason it was found is because there's a museum there with a paleontology program and then they noticed it. Or someone nearby knew about dinosaurs because of this paleontology program.
It all worked out.
Yeah, but it's another good example of why we need local paleontology programs in as many places with dinosaurs as possible, because that's how we find new and interesting dinosaurs for the whole world to appreciate. Looking at the skeletal, it's in really amazing shape. Like I said, it's pretty much completely preserved. And in its head, its teeth do look very carnivorous, but they're not quite like any other dinosaur that I've really seen before, because They are definitely carnivorous. They're very sharp, and they're curved pretty strongly backwards. So, it's good for keeping things in the mouth if it's struggling, or otherwise tearing it off and making sure that it ends up heading backwards towards the stomach where you want the food if you're this Gnathovorax. And it has a very defined premaxilla. So that's sort of, if you're familiar with the way Spinosaurus looks, and it's got that front part of its snout that is very distinctly separated from the rest of its mouth on the roof of its mouth. So it's got a few teeth that are a lot smaller in the front there, and then there's a little bit of a gap, and then there's some more teeth. You also see it in Dilophosaurus. It has a pretty defined premaxilla. This is the same kind of thing. And then there are the biggest teeth right in the front of that maxilla, right after the few small teeth in the premaxilla. And then they just kind of evenly get smaller as they go back in the head. So it's almost like the opposite of our head, where we have like the big molars in the back. These are just getting tinier and tinier as they go back. It's really interesting, really weird dentition.
Better for devouring, I guess?
Yeah, I don't know. I'm thinking maybe these teeth in the back are mostly there just to make sure the food doesn't like fall out of the mouth and keeps heading in the same direction. Kind of like the weird teeth that mosasaurs have on the roof of their mouth. They're not really there for chewing or slicing or anything. It's just kind of there to keep the stuff going in. Turtles have something similar too. That's my best guess. I don't know. It looks weird. Some of the unique things that this dinosaur has is it has just 3 premaxillary teeth, which we haven't seen in other Herrerasaurids. It also has 3 bones in its pinky toe. So even though I was saying, it's got 5 toes, but it mostly uses 3, the one that it's not using, the pinky toe, is still, 3 bones in it. That's like as many as our pinky has in it. So this is a reasonable number of bones. It's not completely vestigial and going away at this point. And I think the weirdest thing is that its tibia is way shorter than you'd expect it to be. It's actually shorter than its femur. And generally, fast sprinters have longer tibias than femora because there's this leverage equation that makes it better for hunting and better for running if you have a longer tibia or tibia plus metatarsal bones than the femur. But this one doesn't, even though it's a carnivore. So it's kind of weird because its legs don't look like it would have been that great of a runner, even though its mouth definitely looks like it was eating meat. I don't know, maybe it wasn't chasing anything that was all that fast or something. I'm not sure.
Maybe it went for carrion.
As a scavenger?
Yeah.
Yeah. It probably did, even if it could run fast, because paleontologists always tell us you don't pass up a good meal.
True.
But you're right, maybe it wasn't fast enough to catch the quick prey, and it had to just kind of make do by being the biggest thing around, scaring away other animals when they hunted something. I don't know. Another great effect of it having a really well-preserved skull is that you can actually see its brain case. So you can see how big its brain was and the proportions of different lobes in the brain, which we can use to infer what kind of behavior it might have had or what kind of senses might have been better than other senses. And based on the shape of its brain, we think that the part of the brain that's responsible for eye, neck, and head movement is really well developed. So it might have had that as an adaptation for hunting. So it was quick with the quick reaction speed with getting its head darting after prey, potentially. Since it's an early Herrerasaurid, they obviously had to do a good cladogram to see if this one helped fill out that whole puzzle of where Herrerasaurids fit in the tree of dinosaur life. And in their analysis, it came out as a saurischian, but not as a theropod. So it kind of pulled it a little bit farther out than some of the other recent analyses. And it actually came out as the very most basal saurischian. So right at that ornithischian, saurischian split, Herrerasaurids immediately started doing their own thing, at least according to this cladogram. And interestingly, too, Gnathovorax was found right next to a rhynchosaur and a cynodont. And I don't really know much about those animals, so I'm just going to quote Riley Black, who said, quote, "The bones of Gnathovorax are framed by the scattered bones of weasel-like proto-mammals called cynodonts and tubby-beaked reptiles called rhynchosaurs," end quote.
It's a good quote.
I love it. So I guess at that time, mammals weren't doing so great. They were doing better than they were in the Jurassic and the Cretaceous, but weasel-like isn't really a great thing to be. And then the tubby-beaked reptile also. Maybe it was prey? I don't know. We don't know. They did say in the paper that it looked like some of the animals might have gotten there after it was already dead and starting to get buried and stuff. So maybe it wasn't preying on these. We don't know. I do think, though, that that's a good reminder that the Triassic really wasn't the age of dinosaurs yet. There were still all these early mammal-type ancestors, like there was Dimetrodon is another similar to mammal. It's another synapsid, just like the Rhynchosaur. And since everything was so well preserved, they did a CT scan of the skull, which is how they found out about that sense of sight and ability to quickly move the neck potentially. And the 3D models are actually available on Morpho Museum. We'll have a link in the show notes for that one. Unfortunately, the skull is pretty smashed. You can download that, the original skull, but I think it could be kind of fun as like a pretend or practice dig or prep piece. Like you can bury it in some sand and uncover it or something. And there's also a really great model of the brain case with the inner ear, so you can see exactly what its brain looks like. You can print that out too if you want.
You can print anything these days.
You can, as long as the 3D files are available. And up next, we have our paper about the Oryctodromeus burrow from Idaho.
Nice.
Yeah, it's pretty cool. It was written by L.J. Krummenacher and others and published in Paleo. I think dinosaurs from Idaho are pretty rare. I definitely don't hear about Idaho in dinosaur news all that often.
The only one I remember is Oryctodromeus.
Oh, you do? That's better than me. I didn't even know that there were Oryctodromeus in Idaho before this. As far as I can tell, I was looking at the Paleo Bio database to just look at Idaho and see what's been published there. Everything that's been published is really close to the Wyoming border in southeast Idaho. So it's, yes, technically in Idaho, but barely. I think, too, that almost all the finds are from the Weian Formation, and this one's no exception. The Weian Formation is roughly 100 million years old, so it's right around that boundary of early and late Cretaceous. And according to the author, Oryctodromeus is the most common dinosaur in Idaho. So that must be why you said the only thing you know from Idaho is Oryctodromeus.
Mm-hmm. And I always remember Oryctodromeus because it's the burrowing dinosaur.
Yeah, it's really cool. One paper described Oryctodromeus as Great Dane-sized, which is a little bit bigger than how I would describe it, because we've seen recreations of an adult Oryctodromeus, and it is 2.5 feet high at the hip and 4 feet long, excluding the 7-foot tail. So maybe that's Great Dane size, but Great Danes are quadrupedal and like pretty bulky, so I don't know. But I guess it gives you the ballpark of kind of how it would stand in a room height-wise. The first Oryctodromeus was named from Montana, and it included a burrow, an adult, and 2 juveniles.
Yeah, and if Oryctodromeus sounds familiar to you, it could be because we covered it as our dinosaur of the day in episode 2, way back when. And we interviewed Anthony J. Martin, who is one of the authors of the paper.
As well as Dave Verricchio, who we've also interviewed. I didn't realize this, but there are at least a dozen other Oryctodromeus individuals known from Idaho. So it's actually not that uncommon of a dinosaur anymore, which is pretty amazing considering the dinosaur was named just 12 years ago.
Mm-hmm.
But among those 12 dinosaurs, some of them are quite complete, and at least one of them is fully articulated, the part of it that we have. But obviously others are a lot less complete. And the paper also lists other specimens from Montana, including the holotype. So I'm not really sure how many of the dinosaurs in this paper are new discoveries versus have previously been published somehow or other. But it's a pretty good overview of all the Oryctodromeus that have been found so far, I think, unless there are other ones that I don't know about. The only other common fossil in the Weian Formation is Macroelongatulithus, which are eggshells, and Macroelongatulithus was probably from a giant oviraptorid like Gigantoraptor, and it is huge. I always think the egg looks like the biggest egg ever, including the elephant bird, but everyone always says the elephant bird is technically bigger, so I don't know. It's the second biggest then. It's super long and narrow. It's weird. You'd probably recognize it if you saw it. But other than those 2 finds, we don't see a lot of dinosaur stuff, and the area is still largely unexplored. So there's a lot of other Oryctodromeus probably still hiding out there, waiting to be found. Interestingly, by looking at the Oryctodromeus, it doesn't look like they were too specialized for digging. They don't really have like big scoopy or scrapey front hands, and it kind of makes me wonder, could other dinosaurs have dug burrows? Because if you just look at an Oryctodromeus, it doesn't really look like something would live in a burrow. We only know it does because we keep finding them buried in their own burrows, which apparently is one of the reasons that they help stay fossilized, is because if the burrow gets filled with a certain type of sediment, it's kind of pre-packaged and ready for fossilization. But even noticing burrows can be kind of tricky because one of these discoveries was almost missed. And by discoveries, I mean the burrow. Eventually, they noticed a nearby concretion that looked like the holotype burrow. And they were like, wait a second, that rock looks a lot like the holotype burrow of Oryctodromeus. And we're looking at an Oryctodromeus over here. We should look into this more.
It's a good eye.
Yeah, because if it's an untrained eye, like to my eye, I was looking at the picture. I'm like, is that the burrow or is this part the burrow? And I already know that there's a burrow in the picture. If you're just out in the dirt and everything's the same color, missing it would be super easy because it just looks like any other concretion, really. Unless there's a dinosaur sticking out of it.
Yep, and Garrett's eye is even better than mine, so. In other news, in the UK, Crystal Palace Dinosaur Park might be getting a new permanent bridge so that visitors can get closer to the dinosaurs. And they mentioned that to us when we talked to them when we visited last year.
Yeah, I think they were doing a crowdfunding campaign back then.
Yeah. So the plans for it to be a retractable bridge so that there's limited access for maintenance, repair, and then limited managed public tours.
So they can swing it out of the way and nobody messes around on the islands.
I guess so. So the last bridge they had, it was removed in 2017. So right now it's kind of hard to maintain the dinosaurs. But the first step is a committee meeting. I'm not sure how many steps there are to this process, so it might be a while.
They did already raise some funding. I'm not sure if it was enough to pay for the whole bridge, but it would definitely be nice to have a bridge there. We missed out on getting to go on the island because they didn't have a bridge.
Yeah. Still a cool view, though.
Yeah, it is pretty cool from afar also.
And last in the news, Marvel just revealed that the first superhero in the Marvel Universe was a dinosaur. So this was in a preview of an upcoming issue, which actually by the time this episode airs, the issue should be out. It's Avengers number 26. There's spoilers here, but it's all from the preview, so I think it's okay to share. It turns out that a T-Rex had a superpower and then defended Earth and guarded its life forms.
Oh, I see. When you said that the first Marvel superhero was a dinosaur, I thought you meant the first published superhero, but this is like chronologically because it's a T-Rex, so it's millions of years ago versus Superman, who was in like the 20s.
Yes.
Gotcha.
Yeah, this is in the Marvel Universe. So the asteroid that killed the dinosaurs hit Earth because actually it was drawn to Earth because Earth needed to make a big sacrifice to bond its cosmic power with the T-Rex. That's the story here. And the T-Rex can blast beams out of its mouth. So it's going to be really interesting to see how many dinosaurs appear in upcoming issues if they're starting here.
Yeah, that sounds a lot like Godzilla, a T-Rex that shoots laser beams out of its mouth or lightning.
Yeah, but it looks very T-Rexy.
Oh, that's cool. And before we get into our interview with Stuart Samhita, we want to remind everybody that there's an amazing new feature-length documentary about dinosaurs coming out soon called Why Dinosaurs, and you can support the documentary by joining their Indiegogo campaign. The campaign is only going until December 15th, so if you want to support them, then make sure you join soon. They've already done a lot of great work to get the ball rolling on the project, including interviewing over 20 paleontologists, fossil hunters, and dinosaur movie fanatics. And apparently that even includes a state senator, which is pretty awesome. They've already had to spend at least $10,000 traveling around the US and Canada, so definitely supporting them will help them continue because travel is not cheap.
They have a few videos, too, from their travels. Well, over the years, too. So there's a video of James's first visit to Dinosaur National Monument in Vernal, Utah.
Yeah, I should mention it's a father-son team, so it's James and Tony Pinto. Yeah, there's some really good pictures all over the site, too, including one with Phil Curry, who's one of our favorite paleontologists, and he looks pretty happy to meet him, too.
Yeah, and he's one of the people that they've interviewed, along with Dr. Caleb Brown, Peter Varison, Dr. Scott Sampson, Dr. Lorna O'Brien, and the list goes on. So they're currently raising funding for the film on Indiegogo, and they want to do more interviews and go to more sites and meet more dinosaur enthusiasts.
Yeah, we might even get interviewed if we're lucky enough to be chosen. You could help make that a reality by supporting their campaign. So if you'd like to support it too, you can get all sorts of different rewards because, you always get a perk for supporting awesome content, as you're well aware if you listen to the show. They have a silver sponsor, which will get you a sticker and a movie link. Even at the lowest level, you still get access to the movie, which is great. The gold level, you get a t-shirt and a sticker. The platinum level, you get a dino bone fragment. That's pretty sweet. You can also get a hoodie, tickets to private screenings or VIP parties. You can also get an associate producer credit, go to the museum with them, or get paleo art, or even become an executive producer in the credits.
Lots of cool perks.
Although the executive producer credit has 4 out of 5 claimed, so if you want to get that, you better hop on it soon. You can support the project now, which is currently on Indiegogo, but remember there's only a couple of weeks left. The campaign ends on December 15th, so make sure you join soon if you want to get in on all these goodies and help them make a great project.
So it's on Indiegogo, Why Dinosaurs, feature-length documentary film if you want to search for it yourself, and we'll also have a link in our show notes.
And now on to our interview with Stuart Samhita.
We're here at SVP with Dr. Stuart Sumida, who is a biology professor at California State University, San Bernardino, and an anatomical consultant to special effect artists and animators. He's worked on over 50 films with many studios, Disney, Pixar, ILM, many more, and as well as games like Blizzard. And he's written books, published numerous scientific articles, and he's led digs around the world. Well, thanks for taking the time to chat with us.
Happy to do it. Thanks for having me.
Yeah, we had your wife on, what was it, maybe a year ago now?
Yep, she's always ahead of me, so that's no problem.
That's like us too.
So I guess first thing we should talk about is your poster at SVP, the Patterns Projects.
Well, we did a couple posters, actually, and that was the first one that went up. The Patterns Project was an interesting thing that happened. I was working with a student from Bournemouth University who's part of their animation and gaming program. Mm-hmm. And they have a great sort of strategy for how they do graduate thesis work, whereas these students do projects where they're trying to get work done that will enhance their portfolio and make them marketable to the visual effects and gaming industry. But they also do something that always helps nonprofits, which is a great way to get your work out there. Nonprofits need the help and they can use it. And it's also really good practice working with really important groups. So what she was doing was finding a way to visually enhance exhibit space at museums. And so what we tried to do is come up with something that was fun for kids. And what was fun for kids is to have something that was that you knew, and visually she could model, and something else that you could model, and then see what the kids thought the intermediates might be.
Oh, cool.
Okay? In terms of shape and so on. And so the kids would predict what the shapes might be from as you move from one type of an animal to another. And then what would happen is that the animation software would then do the morph between, and they could see how correct they were. But the thing that was really great about it is that in addition to doing something visual, the pattern part, it also meant that you could talk to kids about these changes took time. Mm-hmm. So then what it was is it became a way to take the visual pattern as an introduction to talking about change over time. In other words, evolution. Mm-hmm. And kids are great. Kids, when you explain something that makes sense to them, they take it on board. I can try and explain that to their parents, and if their parents have already decided it's wrong, no matter how much evidence you give to them, they'll fight you. But when you give kids the evidence and you let them, you sit back and let them figure it out, it works great. And so that's what happened with the Patterns Project. And that was Cian Warren. She came up with the idea, and I helped provide the animals that we used as we morphed from one to the other. We were originally going to do dinosaurs, but what we decided to do is something a little less common, so the kids would have to think about it a little bit more. Mm-hmm. In the meantime, by the time she finished the Patterns Project with me, she wound up getting a job at Industrial Light and Magic as a creature designer. So she's clearly a very talented partner.
Mm-hmm.
So,
awesome.
Yeah.
And you ended up doing, I forget the name of the group of animals. What are they called again?
Okay, the group of animals that we chose to do are a group called the Synapse. It's the lineage that leads to mammals like you and me. And they're a fairly well-known group. It includes the most famous non-dinosaur, perhaps, the animal with the big sail on its back, Dimetrodon. Well, there are other members of that group that don't have a sail. So that was part of the pattern change. And one of the things that was really remarkable is that the way that CN wound up programming it is that some of the intermediate stages actually wound up correctly predicting the shapes of some other animals that we actually know.
Wow.
So she did a super job on the modeling and the programming.
That's really cool.
Yeah.
And I know on the poster it was saying that could also be used for hypothesizing for animals we don't necessarily know as much about.
And so if you have extremes in morphology, there may well be something not quite so extreme in between. That becomes a hypothesis generator. And even if it doesn't work out, it helps kids understand the scientific method, how you use a hypothesis to guide your endeavor and guide your inquiry while you're doing science.
That's really cool.
Yeah, it was a really great project to get to do.
What was the other poster?
The other poster has to do with some of the good old-fashioned paleontology we've done in central Germany. And again, interestingly, on a synapsid, and in fact, on Dimetrodon, the animal with the sail. It's a famous animal. It's mostly known from North America. And Dimetrodon ranges in size. The different species range in size. Some as big as alligators, full-grown alligators. But the one we have from Germany is about the size of a house cat.
Wow.
It is the smallest species of Dimetrodon ever found, and we found a little bit more of it to confirm that size. And it's certainly really nice to be able to find the kind of material that confirm what you thought before. Because it could very well have just been a juvenile, but the more material we find, it does suggest that it was a fully mature adult, just a very small one. And I got to tell you, if I could have a Dimetrodon the size of a house cat, boy, how cool would that be?
Oh, yeah.
That would be cool.
That's great. So how did you make kind of the crossover between paleontology into entertainment and movies and all that?
Okay, so part of it is serendipitous, and part of it makes sense. One of my best friends is a fellow named Charles Solomon, and for people who know the animation industry, they'll know that he's a very well-known historian and writer. He's written dozens and dozens of books. He's a respected critic, and he knows everybody in the industry. Well, he and I happened to go to grad school together. We happened to be friends. And we happened to hang out together when we were in graduate school. And because of him, I got to know a bunch of people who wound up going on into the animation industry. Well, when we each graduated, we went our respective ways professionally. I went to the University of Chicago for a bit, and he started working, but we always stayed in touch. In fact, we remain best friends today.
Nice.
He was best man at our wedding, in fact. And Charles, I remember when I was in Chicago many, many years ago, called me up and said, "Hey, remember all those guys used to have at lunch together? Well, some of them have jobs now." And I'm thinking, well, that's cool.
Good for them.
And so he asked if I'd be interested in coming back and talking to some of them because they had some questions about animals. So I'm like, oh, sure. And the first set of questions were about horses and wolves. So I went and talked to them, not as an artist, because they're much better artists than I could ever be. Just went and spoke to them as a biologist, as a scientist. And they said, well, a horse is a plant eater and a wolf is a meat eater, and you are what you eat. Right? You are what you eat is one of the most important rules that we teach artists, because what you eat determines your body shape, your body flexibility, the way you move, the position of your eyeballs, all these different things.
Yeah.
And most of those shape differences and movement differences are of interest to animators. And those horses and wolves wound up being Philippe, the Belgian draft horse, and the wolves in Beauty and the Beast.
Oh, wow.
Many, many years ago. The film did very well. I thought it was a one-off at the time. But then they said, our next film is going to be all animals. And I said, oh, what's that? They said, oh, it's going to be called Lion King. And so they asked me if I wanted to speak to them about that too. I said, sure. And we did that. And that movie made a ridiculous amount of money for the time and still. And it was my first screen credit, which was neat. And so over the years, I've had the good fortune of getting to interact with folks in a similar way. For a while, the animation industry sort of boomed as DreamWorks was established and all these other studios were established. And as each one of those studios were established, then I would get to go and visit other ones. And DreamWorks just celebrated its 25th anniversary this year.
Wow.
Of course, there's turnover as well. So whenever we bring in new people, or if there's an animal that's never been done, I still get to go back and work with these folks. It's super, super fun.
Yeah.
And so it involves animals, it involves people, and creatures, because creatures are mostly built out of stuff we already know. So there's no such thing as a dragon. But if there were, we'd have to know how wings work.
Yeah.
And most of the dragons are built out of pieces we already know, whether it's a bat or a bug or a pterodactyl or something like that. And we take what we know about those things and we try and make them look natural enough that the audience is comfortable with the character and therefore comfortable with the story. If we do our job right, they never know we did it.
Right.
But the other part of that is that paleontologists, we deal with partial data. We have skeletons and we have to figure out what these things looked like in life and how they lived. Well, that's what animators do. They don't have the animal. They're not making documentaries. They're building it and trying to give you a feel of how a character lived its life or acted. And so there's a lot of overlap in strategy between paleontologists and animators. It works out really, really well, actually.
Yeah. So something like the movie that just came out, Abominable, because none of those are.
Okay, so here we're talking about a creature. Okay, and there's a couple ways to look at it. Most creatures that you see on film are made of things that we already know. Right. So, for instance, the Beast in Beauty and the Beast is an amalgam of a bison and a dog and a bear and other things. If you look at Pegasus is a horse with wings, but so he's like a horse and he's got wings. Now, Abominable, the Yeti, is a big furry sphere. He's got 2 arms and 2 legs, which meant that we had to go inside that creature, see what volume was taken up by the head, see what volume remains for us to build a proper shoulder, proper hip, elbows and knees, hands and feet. And so we know that character was a mythical character, but if it existed, it had to have the pieces that would make it move. And that means that we have to have a very, very keen understanding of how skeletons work. Now, we pick and choose the skeletons that we use. So the skeleton inside of him is mostly a mammalian skeleton, but we used a few sort of dinosaurian shapes and a few non-primate shapes to sort of get the shape we wanted out of it and get the joint mechanics to work in a way that he could then move that looked natural. He doesn't really exist, but if he did, how would those joints have to work so he didn't break his leg every time he walked? That's sort of the strategy that you have to take.
Yeah. And then what about differences between male and female characters?
Well, okay. Now, that is one where we do all sorts of stuff that don't necessarily exist in nature. The classic example of which I had nothing to do with is if you look at the opening sequence of 101 Dalmatians, a classic Disney film, every one of those animals walks like its owner. Well, those are caricatures, okay? We understand male-female differences, what we call sexual dimorphism, best for people because we are people. It doesn't mean that the sexual dimorphism doesn't exist for other animals. For example, in raptorial birds and probably therefore dinosaurs, the females are larger and more robust. Okay. The flip side of the case with humans, men tend to be somewhat heavier and more robust than females because men hit puberty later. So they grow for a longer period of time. Women can also bear children, whereas men cannot. So it means their hips are built differently. And those kinds of things, which we study in excruciating detail, say when we do human anatomy for our nursing and medical students, well, we teach that to the artists as well, because they are then expressed in body proportions, shape, locomotion, and movement, which is movement is what animation is all about, and movement helps you act. So we spend an enormous amount of time on the differences between males and females. Now, sometimes we anthropomorphize that. Okay, so a great example was the film Zootopia.
Oh, yeah.
Zootopia, all the animals walk around like people. And real human people, women have longer legs and shorter torsos than do men. Well, if you look at Judy Hopps in Zootopia, she's got a really long torso, but it's not as long as her friend, who's a male. Okay? And yeah, they walk around like people. But one of the interesting things about that project is that there was still a lot of biology in it because the shapes of the heads had to remind you of the animal. And what a lot of people don't know is those artists went to the Los Angeles County Museum of Natural History and spent an enormous number of hours studying fur.
Wow.
So that the fur of every character was different and reflected the kind of animal that it was supposed to be. So they looked at giraffe pelts and fox pelts and polar bear pelts and cheetah pelts, all these different kinds of things, so that even though they walked around like people, the texture of their fur still seemed correct.
Nice.
It's caricature, right?
Yeah.
There's got to be something you recognize, otherwise it doesn't work. It could be very, very exaggerated, but there's got to be something. And that was part of what they used to hang their hat on.
Cool.
So we kind of have to ask your work with Jurassic World then.
So I'm a paleontologist, and people always say, oh, Jurassic. You must have worked on that. And in fact, the early films, I had nothing to do with them. Mm-hmm. And then people would always say, oh, well, you're a paleontologist. What's wrong with the Jurassic Park movies? And I was like, well, we've been waiting to see that all our lives. Mm-hmm. Really? So I love the dinosaurs in Jurassic Park. It's the people that I thought were ridiculous.
That's true.
Paleontologists don't act like that. But it's a movie. We're not making documentaries. Okay, fine. Okay. You can quibble. The arms on the T-Rex are a little too long. Things like that. But they're nitpicky things, okay? Many, many, many years later, after having established a relationship with Industrial Light and Magic and Disney, when the Jurassic World films were being made, part of the visual effects crew was at Industrial Light and Magic in London. And I get to travel back and forth to London quite a lot because there's quite a few visual effects studios there. And ILM London found out I was in town and said, would you be willing to come and talk to us about dinosaurs? And I got to meet Glenn McIntosh, who has been one of the guests on your show. Mm-hmm. And he and I got on like a house on fire. And and we started talking about the movement patterns of a variety of the different characters. And it wasn't like they haven't built these things before, but what I got to do was come in and with some of the artists were new and hadn't worked on the project and got to help to get them all up to speed with Glenn so that everybody was on the same page as they were animating these characters. I didn't tell them to change the T-Rex or anything like that, but I got to talk to them about all the major groups of dinosaurs, how they're built and how they move. And that's the key. I want them to move in a way that the audience feels makes sense for the characters. So that was for the second Jurassic World film.
Gotcha.
Industrial Light and Magic has always, ever since the first Jurassic Park film, has always been the lead studio on that. Many studios work on films these days, and they often share assets. They have shared some assets on the Jurassic films, and I've worked with some of those other studios as well. I'm not supposed to talk about who they are.
Sure.
But I can tell you that there has to be cooperation because there's so much digital work that goes into films these days. People are amazed at how much goes into them, but what's even more amazing is how much more goes into them now than did originally. The original Jurassic Park film had very little digital work. There's puppetry, there's robotics, but now it's almost all done in computers.
Yeah.
So what kind of work did you do for an Indoraptor then?
Okay, I didn't work on. Okay, to be fair is fair. I didn't work on Indoraptor specifically. The person who deserves credit for that is Glenn. Okay, Glenn is the one who designed it, and it was very, very funny. I got to talk to him about it and was saying, aren't dinosaurs already amazing enough that we don't have to make up a fake one? But he was given his marching orders, and he did a really interesting job of coming up with a character where the pieces went together in a way that made sense. Right? See, this is what we do when we do creatures. You sew them together in a way that seems like it would work if they really existed. So I didn't have anything to do with it other than to talk to the artist and say, look, this is how a theropod moves. Okay, this is how a raptor moves. This is how it balances. This is where it's going to place its foot when it has to balance from side to side. One of the interesting things about theropods is they're bipedal. Their posture is different from ours. Okay, their backbone's approximately parallel to the ground, whereas ours is perpendicular to the ground. Okay? However, because they only have two limbs that touch the ground, they do have to shift their weight back and forth a little bit so they don't fall over to the side. We do that too. So we talked about those kinds of things, the mechanics with them. But when it came to design, credit where credit's due, that credit goes to Glenn.
Yeah.
Cool.
So, yeah.
Great. So we've talked about, you kind of have these like 5, 6-ish rules for anime. And I think we've covered some of them for what you are, what you eat.
Yeah, the first one is you are what you eat. What you eat impacts your body shape so much as an animal that if you know what an animal eats, you know a ton of things about it. Because we can't study everything. Okay? Just like a vet doesn't study 30,000 species of vertebrate, they study a pattern that they can use for many. Okay? So that's the first one. When it comes to people, whether you're male or female matters. Okay. So, and, you know, with all due respect to my, to our listeners who are of varying, you know, perspectives, biologists, we don't use the term gender. We use the word sex. Okay. Because sex is what your chromosomes give you, not what you choose. And sometimes, and there's great overlap. I understand, and there are gray areas. But when we talk about it, we talk about, are you physically designed as a male or a female at birth? And what does that have to do with you biomechanically? Okay. And for the ability for, say, childbirth. So that's another next one. Sex matters, okay? Especially if you're a person. Okay. Age matters. That's another one. Babies look different from adults. Now, this is really important, not just in art, but in science too. My dad's a pediatrician. Little babies aren't built like adults. And there's a reason why we have pediatricians, because kids are different. Okay? So kids, adults, and old people are different. Age matters. Okay? Size matters. You are what you eat covers about 80% of the animals that we animate. But some things are really big and some things are really little. Elephants are really big. And when you're really big, you can't run. You can walk really fast, but you can't run. Right? On the other hand, if you're really, really small, you can do and endure things that a big thing simply cannot. And a mouse has a much more flexible backbone than, say, even the most flexible of carnivores, for example. So size matters. And then finally, if you understand that what you eat matters, what your sex matters, what your size matters, and your age matters, then if you take all those rules and put them together and to create a creature, most of our creatures' parts are following those other 4 rules. There are more minor things off to the side that we have to consider, but those are the big 5 that we talk about in animation most. It's by no means the only thing. So for instance, things that fly and swim are special. Okay? Flight trumps almost everything when it comes to body adaptations. So if we're going to have a thing with a lot of flying things in it, well, then we just have to learn flight physics. Okay, fair enough. Or if you have things that swim, well, you just have to deal with the viscosity of water. You just have to do that. But those first 5 are the ones that cover a lot of the territory of a lot of the characters that we work with.
Awesome.
Yeah.
Wonderful. For our listeners, if they want to find out more about you and your work, where's the best place for them to go?
Okay. Well, I'm very, very fortunate that my university is supportive of what I do. So our university has websites that direct you to our work. I'm at California State University at San Bernardino. So you can just go to the university's website and find some of that out. I do have my own website. It's a little out of date, but you can go to my website as well. It's just stuartsamhita.com. We have an IMDb page as well. And every once in a while, you'll find me in bits and bobs of these making of things on some of the films. So you can find us there as well. And, you know, if you just cruise the internet, you can find some of the work we've done as well, especially when it comes to big film festivals. Some of the big film festivals we've worked at, like Animex in Northern England and BFX in Southern England, have posted workshops. Animation Mentor has posted some of the workshops that both Elizabeth and I have done. And so we are working on a book. We're writing a book right now. And we were originally going to call it Anatomy for Animators. But now we've changed it to Anatomy for Animation because the pipeline in animation is much more complex than it used to be. And there are many other parts to it that we didn't even envision 15, 20, 25 years ago.
Awesome.
So
when's that coming out?
Soon, I hope. It's been in the works for many, many years, but DreamWorks Studios has been supportive, and we're getting a lot of the writing done this year. Was our hope.
Wonderful.
Yeah.
Well, thanks so much for chatting with us.
Well, thank you for having me. I've looked forward to joining your group, and and I appreciate you coming all the way out to SVP in Brisbane, Australia, to talk to us.
Yeah.
Thanks again, Stuart. We had an awesome time talking about some non-dinosaurs, but also animation, because we don't get to talk about that too often. And if you're listening to this and you want to hear Dr. Elizabeth Rega's interview, Stuart Samida's wife, then head over to episode 183. That's the one where we interviewed her.
And now onto the dinosaur of the day, Pelecanimimus, which was a request from Dinosaur 4602, so thanks. It was a basal ornithomimosaur that lived in the early Cretaceous in what is now Spain in the Las Hoyas fossil site, and the holotype consists of the front half of the skeleton, the skull, lower jaws, neck and back vertebrae, ribs, sternum, pectoral girdle, complete right forelimb and most of the left forelimb, as well as soft tissue at the back of the skull around the neck and front limbs.
Pretty good.
Yeah. It was about 6.6 to 8.2 feet or 2 to 2.5 meters long, and it had this long, narrow skull.
Sounds pretty big for a pelican.
Yeah, well, as you can guess, the name means pelican mimic, but we'll get to that. So Pelecanimimus had wrinkled skin impressions, so probably didn't have scales or feathers, though we're not 100% sure. The soft tissue remains found show that there was a small skin or keratin crest on the back of the head and a throat pouch, this gular pouch that's similar to what modern pelicans have. They also found specialized tongue bones in the neck. So it may have been like a crane and waded into lakes or ponds and caught fish and stored them in its skin flap. Pelecanimimus had hook-like hands with fingers that were all similar length with straight claws, and had the most teeth of ornithomimosaurs. Most of them were toothless. It had about 220 small teeth that were heterodont. The ones in the front were broad, the ones in the back were blade-like, and teeth in the upper jaw were bigger than the teeth in the lower jaw, so they're all different.
That's super weird, having sharp teeth in the back.
Yeah.
What's it doing?
Yeah, so some of the teeth were unserrated, but it was possible that it used its teeth for cutting and ripping, and it could work like a beak, like a slicing effect. This is according to Perez Moreno and others. Muscle remnants were also found, and Gregory Paul suggested that Pelecanimimus may have been able to fly or descended recently from an animal that could fly. That's based on its large sternal plates, and that may mean that there were muscles for flying. The type species is Pelecanimimus polyodon, and as you mentioned, the genus name means pelican mimic, and the species name refers to its many teeth. It was found in 1993 by Armando Diaz Romero and described in 1994 by Bernardino, Perez Moreno, and others. The holotype's now at the Museo de Cuenca in Spain, and other animals in the same time and place included theropods, sauropods, lizards, salamanders, early mammals, pterosaurs, and crocodilomorphs.
I wonder how many of them that Pelecanimimus tried to eat or got eaten by.
All of them.
It was all either eating or getting eaten by everything.
Yep.
Okay.
That's how nature works.
I guess so. And our fun fact of the day is that we've talked about cursorial animals before, but there are also graviportal and the lesser used metaportal animals, which are other ways to describe how fast animals were. So cursorial means designed for running. They tend to have very long and strong legs. You can think of an ostrich, a cheetah, and most theropods. They tend to be pretty quick and they're cursorial. They look like they're going to run. Graviportal means that they're set up only for carrying massive weight. So lots of the bones are getting fused or interlocked together for strength, but it reduces flexibility and limits speed. You can think of giant tortoises are usually the example people give. I think sauropods and elephants might kind of fit, but they only fit if you don't use the term metaportal, which is kind of nearly graviportal. It's for animals that have legs that are adapted to carry more weight, but they have some features of cursorial animals. So it includes animals like ankylosaurs, ceratopsians, and some of the biggest modern animals like hippos, rhinos, and elephants. And yeah, it's probably sauropods because we think they could still move pretty quickly. Elephants, for example, can still run faster than people can. So calling them graviportal, they're not like a tortoise where they're just there to hold up their weight and can't do much else. But in general, we usually just see cursorial and graviportal used. And if you do that, then a sauropod's probably graviportal.
And that wraps up this episode of I Know Dino. Thanks for listening. Don't forget to subscribe so you don't miss out on any new episodes. And if you'd like, you can join our growing community on Patreon, patreon.com/iknowdino. Thanks again, and until next time.
Good day.